Dear students, welcome to TomTech Academy YouTube channel once again. So today we are going to talk about another video series in separation unit operations. We are going to discuss the control of distillation columns and the process dynamics and control video series. So to start with, as you know, the distillation columns are mostly used separation equipment in downstream facilities, and their control directly affected by production rate and quality at the end of the day. So in the oil refining, the distillation is used, and not only the oil refining, the other process industries as well, they are mostly known for the separation purposes. This is the very generic picture for the distillation column operations. So your feed going into the distillation column, as you can see, the lighter products with the hot streams going above and the heavier ones will go down. You have the overhead vapor going into the condenser. Then after condensation occurs, it will be collected in the overhead accumulator or reflux drum. From this reflux drum, you have two streams. One of them, the achieved distillate, in which you have already satisfied your product quality and production rate, and your reflux is going back to the distillation column. Coming to the bottom product, the bottom product is going into the reboiler. After heating this product, the most important valuable ones will go back to the distillation column. Undesired ones will be separated as the bottom product. Keep in mind that in some refineries, we use this bottom product as a new product as well. Some of them are used for sales, some of them are sent back to the distillation column as a feed. Let's see this presentation. In this slide, the same principle, the feed is going to the distillation column or tower. The things that you have seen is the trace of the distillation column or tower. So as you can see, the most important condenser is used here, and the condenser, after condensation happens, it will be collected in the reflux drum, and with the pump, some of the products will be sent back as a reflux to the distillation column, to the first tray or the second tray. You can simulate it in the Aspen-Hysis or Plus to get in order to know the exact from the which tray it will be sent. And the distillate product will be sent for the sales or other purposes. And the reflux, and also the bottom product will be sent to the reboiler. The bottom product will be sent for the sales or the other purposes as well. In this slide, you will see that so distillation columns, as mentioned before, have to be carefully operated. So because at the end of the day, we need to achieve the production rates and the product quality. So the production rate and quality are the main factors for the distillation column specifications. There are three main objectives in general for the distillation column control: to set the stable conditions for column operations, to regulate the conditions in the column so that your products always meet the required specifications, to achieve the above objective most efficiently, which are our required specifications. It could be either done by maximizing your product yield or minimizing your energy consumption. So if we look at the process variables like temperature, pressure, flow rates, levels, and also compositions, they must be monitored during the distillation column unit operations, and they must be controlled in any distillation process. The most important four variables, which are temperature, pressure, flow rate, and levels, these are in generally operated and controlled in all equipment. But additional to some equipment like distillation column, you need to be careful with the compositions as well, because at the end of your day, as we mentioned before, your product quality and production rate determine your meeting specifications or not. Also, in some rotating equipment machineries like compressor or pumps, you might also control additionally its speed. So these process variables like temperature and pressure, flow rate and level, all of them are interconnected by each other, and it connects and also it affects one another, whereby a change in one process variable will definitely result in change in other variables too. Hopefully it is clear, and we'll be continuing with some general guidelines. While you are designing your general distillation column, you need to be careful with its unit operations. As we mentioned before, we need to control the pressure, flow rate, temperature and level, and also additional the compositions. Let's have a look at them, which are the general guidelines. If you want to control your column pressure, you need to be careful with the controlled at constant value. It should be always at constant pressure. You might have additional pressure loss through the trays, but in general, the most important factor is the pressure for distillation column, that you need to be set it as constant value. Coming to the feed temperature. The feed temperature controlled by feed preheater. Prior to preheater, the feed may be heated by bottom product via feed bottom exchanger. So if we want to have a look at how the preheater is used for heating the bottom product, in general, your bottom product will be sent to an exchanger or preheater, and the product that you got, like at the set point, it will be sent to the column again. So this product will be your new feed, and new feed temperature will be set by this preheater. Top temperature of the column, bottom temperature of the column. In general, if you want to control only one temperature, it will definitely be and also done with the controlling by varying the steam to reboiler. The steam is the utility, hot utility of the reboiler. So it will be controlled with the bottom temperature. But if you have a chance to control also the top side, you could control it by varying the reflux. So this is your two options. We discussed pressure, temperature, and let's have a look at the compositions. It's controlled by regulating reflux flow if you want to take a composition test from the distillate, or if you want to have a look at your bottom product, it could be controlled by boil up ratio, your boil up reboiler vapor. So, and additionally, sometimes we could also control the feed flow rate. So this feed flow rate is often set by the level controller on a preceding column. It means that it is independently controlled if fed from storage tank or surge tank. We'll continue with this picture. If you remember from the first slide that, so after the reboiler, some of them will be sent to the column itself, some of the bottom product, which is this blue line, will be sent to preheater, and it will be sent to the feed. So this feed temperature will be taken its set point from the preheater conditions. Let's continue with the pressure of distillation column. So in general, pressure is often considered the prime distillation control variable because your pressure will affect your temperature, condensation, vaporization, compositions, volatilities, and almost any process that takes place inside the column. So all of them is very important because in the previous slides we just discussed that. So the pressure affects the different variable, and in general it affects the general unit operations and control of the distillation column. Therefore, you need to be very careful while designing your control system. So how would you control your pressure in the distillation column? Column pressure control frequently integrated with the condenser control system. So it means that while you are discussing the pressure control, you'll always mention the three main methods for pressure and condensation control. This is gonna be your vapor flow variation, flooded condenser, and cooling medium flow variation. I have already put the 3 different diagrams for these pressure controls, but also keep in mind that we'll not discuss every detailed methods here, but you could be searching on the internet for more detailed explanations for the level, temperature, pressure, compositions, and all. So we'll put some reference links in the description of the video. You could have a watch and also to add to your watch list in the future. Let's continue with the brief introduction to each of these methods. So in the first method, which is the vapor flow variation. In general, this is the most simplest direct method for column producing a vapor product. So the pressure controller regulates the vapor inventory and therefore the column pressure itself. As you can see, you have the distillation column here, and its overhead vapor will be sent to the overhead accumulator or reflux drum with another name. So you have the cooling water supply from this line as well. As you can see, from this overhead accumulator, you have the additional vapor product that leaves the accumulator. You could control your vapor product by manipulating the control valve, pressure control valve on the vapor product line, and with the help of your overhead vapor. There is one important factor to always consider, that the proper piping of the vapor line should be considered to avoid liquid pockets in these lines. Hopefully it is clear, and we'll go to the next one. In the next example, I'll discuss the flooded condenser. This is a little bit more interesting, and also in some part of the refiners they are also used with the flooded condenser. So in general, this method is used in the case of if you have the total condenser. So if you have the total condenser, you could use this method because you could generate the full product of the liquid. Part of the condenser surface is flooded with liquid at all times. You can see it here. Your part of, as I mentioned before, part of the condenser surface is flooded with liquid at all times. And it means that the flow of condensate from the condenser is controlled by varying the flooded area. Increasing the flooded area, which means that by reducing the flow, as you could increase your area, your flow will decrease. It increases your column pressure. P is getting increased. It means that you have the less surface area for condensation. So your overhead vapor is used to be sent to the overhead accumulator. You have also the equalizing line here. In order to equalize the pressure at given set point, you will always operating with this line as well. It might be useful to connect and also to be operating with this line. So as you can see, whatever happens, like the control, it doesn't matter. Your reflux will be sent back to the column and liquid product will be sent for the other purposes, for downstream facilities or the sales. We'll continue with the last method, which is the coolant flow. This is also one of the most used methods in the condenser pressure control systems. Pressure can also be controlled by adjusting the flow of coolant to the condenser. So you can see it here, flow of the coolant to the condenser. In general, the condenser utility is the cooling water or the other, let's say the cooled medium. So for example, coolants. So for example, in this example, this is like the cooling water supply, cooling water return line have been mentioned. So you have the control valve on the supply line, and via this control valve, you are getting some result for your the pressure. At the overhead vapor, you get some pressure, and while the manipulating this valve, you always try to make it at the set point, given set point. Operation using cooling water can cause sometimes even fouling problems at low flow conditions for the heat exchanger, when cooling water velocity is low and also the outlet temperature is high. This is, as I mentioned, one of the most important and also the frequently used method in the industry. And we have also two additional methods, which I haven't mentioned here, but you could use, for example, one of them is venting excess gas to flare, or the pressure control using some inert gas. When column pressure falls, an inert gas is admitted to raise the column pressure. We'll continue with the temperature control and the composition control. In the temperature control, column temperature control, I would say that perhaps the most popular, famous way of the controlling product compositions. In this case, control temperature is used as substitute to product composition analysis. So you will take from this line distillate and from this line the bottom product. So ideally, both top and bottom compositions should be controlled to maintain each within its specifications. So if you're gonna watch one of the API related videos in distillation column control, you will understand that what does the specification mean in the distillation column, what is the product quality, why we need that. In general, we are going to control the distillation composition or bottom composition while manipulating the distillate flow, bottom flow, or the necessary heat exchangers duty, let's say. So if I gonna tell you control variable is distillate composition, then your manipulated variable is your distillate flow. Then disturbance variable is your feed flow. Coming to the bottom compositions, and here your manipulated variable will be your bottom flow, and your disturbance variable will be feed compositions, or is again the feed flow. So, and also, if you want to control your temperature in general, the temperature in the distillation column, you could use the, let's say, the reboiler steam, its hot utility, to manipulate this temperature, or you could use your, in general, the reflux feed stream to control your top, let's say, the top side of the distillation column. But there is also one very good quote and also saying for the distillation column that's written in Chemical Engineering Design book, that so you could be as creative as possible. So that depends on you when you are designing any distillation column or any plant operations. Just you need to be always careful that your control system should be independently working, and also it should be like the robust control. You might have the additional control to control another things, and it could adding some complexity to your system. Therefore, you need robust control and also the smart way of the controlling and unit operations of the any equipment. That doesn't matter being a distillation column, pump, compressor, any separators, and etc. But it's very important to consider these factors. Up to this point, we just discussed the general temperature with the compositions, some disturbance variables, pressure, flow rate, and etc. But if you want to see like some kind of the control loops, we could have a look at this one. So for example, at the bottom, you have the level control going with the flow control. On the left, you have the flow control. Most probably it will be controlling the composition or temperature. It will be also could be the composition or temperature with the boil up ratio and etc. You have the this is the TC. Yes, it's TC, temperature control, and this temperature control is done with the flow control as well. So you have the level controller, you have the flow controller here as well, because you are controlling the level of the reflux drum or overhead accumulator with the help of your reflux rate. Sometimes it's also used like here the pump, and you could control your pump speed, the level of the overhead accumulator, sorry. And you have addition the flow rate control at the inlet of the distillation column. This is very generic picture, but in general in the industry it is, I would say, that much more difficult and much more complex than this. Another example taken from the Google, it's the again the distillation column. So there are so many things that's controlled. So you could see that first of all, this is your distillation column. First of all, try to understand what are your utility connections, what are your equipment written here. So on the highlighted diagram, you have the distillation column. From above, you will have the overhead vapor going into your condenser, as you can see. So this condenser have the cooling water supply on this line. Then it will be sent to the overhead accumulator. You could see that this is the level controlling mechanism that's shown here. So from this side, some of them, from the, let's say, the reflux part, it will be sent back to the system via this line to the distillation column. And some part of it will be sent as a benzene, as a distillate product. Also, from your overhead accumulator, you have the fuel gas sent here. So if you remember how we were controlling the pressure, you could answer the question in 3 ways. The first one was our flow variation, which could be done on this if you have the, let's say, the pressure control valve on this. The second one is the flooded condenser. If your condenser is already, let's say, the total condenser, you could use this method. The third method was the coolant flow rate control. If you have the cooling water flow rate control valve on this line, you could also regulate and control your pressure condenser system in the distillation column. Coming to the temperature, you can see it here. You have the TI, and also here's the temperature transmitter. Your temperature transmitter is actually controlled with the reboiler. This is the reboiler shown here. This is a different type of the reboiler, let's say. So you have the steam inlet and also the already cooled down the steam outlet, or condensate we can call it. So it is controlled by the help of this steam inlet. As you could increase the steam flow rate, your temperature is getting increased. If, let's say, that your set point is 50 Celsius, and in the distillation column your temperature started to decrease, like 48, 46 or something, I'll write 46 degrees Celsius. So then the let's say the control room technicians, the first action is to start to increase the steam flow rate to the reboiler. So as the time passes, it will definitely going into the 50 Celsius. But sometimes there are some different ways. So for example, if your bottom product is not used anywhere else, and it could be sent to the preheater, let's say, I'll draw preheater, and this will be sent as a feed, then you have the second option. You'll increase the increase the outlet temperature of your preheater. It will be preheating a little bit more the bottom product, and it will be sent as a feed. And it means that with the help of heat transfer and also, let's say, the mass transfer, especially the heat transfer bath, so the heat transfer will help you to reach again to the 50 Celsius. So this is very generic explanation on the distillation column temperature and pressure control that we just discussed. Also, you can have a look at the compositions on the top product, on the bottom product. But my recommendation, first of all, try to understand what your distillation column looks like. So where is your distillation column? What are your heat exchangers? Where your condenser and reboilers located? What is your utility to condenser? What is your utility to reboiler? What are you controlling in distillation column? So it might be not necessarily to controlling your pressure and temperature. This is a very rare case, but there might be some exceptions. But always keep in mind that your pressure and temperature definitely affects your separations and distillation principles in the columns. And you need to also look for what are your controlled variables, what are your manipulated variables, and what are your disturbed variables. It definitely will help you to read the old PNID and also understand the distillation column unit operations. So actually that's all. And there are some, like the references, just 2 references that I have put here, but some of them will be again to be attached into the description. You can use it, and there are some really important recommended videos that we have attached to the video. So if you have any special desired topic to be discussed in the unit operations, or any sizing, any equipment design, any related topics in the chemical engineering, you could drop in the comment section and we'll try to record a video for your learning. Thank you very much. Have an amazing day.